Today I'm here to speak about the energy conservation. The topic here is modification in the existing NRL cogeneration plant boiler feed water system as a means for increased efficiency and operation and energy saving. This paper will, okay. This paper, at the end of the paper, we can see the wonders of pressure control valve and the shut-off valve. How a pressure control valve and how a shut-off valve leads to a very big magical, wonders. How they lead a great saving of around 3,000 megawatt per year, or and savings of 1 crore per year. We will see in this subsequent slides, sir. This is just about our location. It's the largest refining capacity in the Assam. So we'll just skip to the topic. Now this topic describes how a pressure control valve and a shut-off valve does a magical work. It brings about revolution in the cogeneration plant boiler feed water system. Along with that, it brings about interchangeability, flexibility, reliability, and redundancy. All these factors come into picture with the just help of PCB and SDB. And at present, we are running 4 numbers of HT motor pump. Then these 4 numbers of HT motor pump will reduce to only 2 numbers. So there is a huge savings of from 4 number of pumps to only 2 numbers of pumps. And total money benefit is 1 crore, and total energy saved is around 2,974 annually megawatt, and CO2 emission, that is 1472 annually. Now I brief about the present condition and how the modification is changed, and how the changes will be occurring the benefits. The total, this is the present condition of boiler feed water system. Now the present consumption is 173 ton per hour, and it is, we have 2 systems of boiler feed water system. One system is, this is the system, refinery low pressure boiler feed water system. It is delivering at a pressure of 35 to 40 kg, and the maximum flow is around 68. It revolves around 50 to 68 ton. And this is the one system that is low pressure, and the other system is the high pressure. This high pressure, we have got 2 systems. One is for HRG, heat recovery steam generator. The consumption is 65 ton, and along with that, there is 10 ton of water going to MSP, that is motor spirit plant. And the other system is the UB, that is utility boiler. It consumes around 30 ton of water per hour. Now, this is the low pressure, and this is the high pressure. Now, at present, there is no link with the high pressure and low pressure. So then these two. This is the 2 pumps out. Now presently, this red color mark, this 1 pump is running, these two are also running, and this turbine pump also running. So there are 1, 2, 3, 4. There are 4 pumps running now at present. Now these 2 are the refinery pump. The whole refinery is dependent on the 2 pumps. Now if 1 pump is running and the other pump gives the problem, and there is a very huge risk of refinery. The whole refinery may come to a standstill. The refinery may get tripped. And if the running pumps also cause problem, then the whole refinery will come to shut down. So there is a very huge risk, and reliability is very risk. And secondly, this high pressure, there are 6 pumps here, and there are 2 pumps here. These 6 pumps and 2 pumps cannot run with each other, because we need to close this valve, because if we open this valve, then all these pumps will be interlinked, and when there is power failure, this turbine should be running. One turbine should be running during the power failure for the safe shutdown of the refinery, because it has to supply steam, and also it also cool the reactor bed of the different refinery. So all these problems will now be solved with a very simple way. Now see, there are 2 modifications. The first modification is, will be by installation of PCB, that is pressure control valve between low pressure and high pressure. Now we can see this high pressure line can be linked with this low pressure line. There is a 65 kg pressure, and here there is only 35 kg. Now by using the pressure control valve, we can link with the high pressure and low pressure. Very simple modification. Now the low pressure line can be used through the high pressure line. So now these two pumps can be again linked with all these 6 pumps and then these 2 pumps. Now, instead of 2 pumps, there are additionally 8 number of pumps. So, the refinery will not trip at the cost of refinery pump, 2 pumps. Now, there are all these pumps are now interlinked. So, the huge amount of reliability, flexibility, interchangeability has comes into picture. Now, second modification is this shuttle valve. This shuttle valve is installed here at the downstream of this turbine pump. Because if we install this shuttle valve, then when there is power failure, this turbine pump, this network will be shut off here. So the main intention is to stop the water supplying to the whole network. Because if we supply the water to the whole network, the pump will get overload and the turbine will trip. So we will not be getting the emergency steam, emergency water during the power failure, and that will lead to damage of the reactor bed, damage of the different equipment. There will be no cooling. So the huge risk of reliability and flexibility has been solved. Now, now at a glance, now taking the 2 modifications at a glance, there is a total of 173 ton of water consumed can be made by only 2 pumps. Earlier there were 4 pumps, now there are only 2 pumps running. This red pump and this red pump, they will be running, and these 2 will be supplying water to the whole refinery. So no need of 4 pumps. Instead of only 4 pumps, we can run only these 2 pumps, supply the whole network water, to the low pressure water, to the high pressure water, to HRG 1, 2, and to MSP also, and also to this utility boiler. So there is no risk of tripping of all the units. So there is a huge safety, huge energy saving with this just 2 modification. This is the just benefits. So now we can benefits both the high pressure, low pressure interlink. All the pumps are interlinked and interchangeable. Total demand of 173 can be made by just only 2 pumps. Now earlier 4 pumps, now 2 pumps running. This is the cost saving we have this one, total savings of 2,974 megawatt annually, and a monetary benefit of around 1 crore. Yes, sir. So we can just see with the very simple modification of installation of pressure control valve and the shut-off valve, the whole refinery can be supplied with just only 2 pumps, which earlier was only 4 pumps. Okay, sir.
Question, please.
Yes. Diagram, sir. Okay, sir. Okay, sir. Fine.
First of all, one thing is that you have now reducing the pressure from the
65.
high pressure boiler.
Yes, sir. Yes, sir. This pressure is 60.
65 kg.
Okay, sir.
And you are 65 to 35 kg you are using it.
Yes, sir. Pressure control. Yes, sir.
So you are around 30 kg pressure drop you are taking.
Yes, sir.
That is your loss of energy.
Yes, sir.
That's number 1. So this is your loss of energy whenever is there. So this you can utilize.
Yes, sir.
This is that is because one day any kind of a cogeneration plant or this kind of a feed water system, all these things.
Yes, sir.
First of all, pressure reducing valve, control valve has to be avoided.
Yes, sir.
Heat, no.
Yes, sir. That we are thinking of.
No.
Okay, sir.
Because what happens, this is the wastage of energy.
Yes, sir.
So what one possible solution is that you put a small turbine
Yes, sir. We were thinking of, sir.
turbine unit from 65 kV to
Yes, sir.
35 kV.
Yes, sir.
Instead of
Pressure control.
PCB
Yes, sir.
is replaced with
Yes, sir.
the pressure turbine
Yes, sir.
operating from 65 kV to 35 kV.
Yes, sir.
So that whatever power will be generated,
Yes,
we see that what pumping can
Yes, sir.
run.
Yes, sir.
Maybe that is either a auxiliary boiler, fish pump or something you can run on
Yes, sir.
this one.
Yes,
So that energy you are
Yes, sir.
resolving.
Yes, sir. So exactly, sir. Exactly, sir. In that regard, sir, now we are calculating the energy saved that we are by stopping the extra 2 pumps and the energy lost here. Now we are in the positive side, and in addition with that, we are also looking forward your suggestion, sir. If we can install the back pressure turbine instead of this pressure PCB, then we will be getting much more energy savings, sir.
That you have in mind.
Yes, sir. We have it. Yes, sir.
Because that is one
Exactly, sir.
offer.
Exactly.
That is to a man who knows this system.
Exactly.
It looks a big
Exactly, sir.
question mark.
Yes, sir. Exactly, sir.
So many pumps here.
Sir, this is because, our HRG 1 and HRG 2, each is designed of 130 ton per hour, sir. And also in the keeping in mind the future scope, we kept the extra pumps, sir. Because we are in the expansion process, very soon our NRL is going to expand from 3 million metric ton to additional 6 million metric ton, sir. So we will be distillating around 9 metric ton.
Because you have now actually, okay, this side is the turbine driven.
Yes, sir.
But 5 electric driven.
Exactly, sir.
So 5 electric driven means your, so either it could be 4 into 25%,
Uh-huh.
4 pumps are running.
Yes, we present.
One electrical standby.
Yes.
Pumps running, one electrical standby.
One standby, sir.
Number of
Yes, sir.
that is you must
Yes, sir.
minute for that.
Yes, sir. We are told, sir.
The pump can be reduced.
We have reduced it, sir.
It looks like
So,
more because today nobody gives a 25% 4 pumps.
yes, sir.
Either
So that is come in the,
50%.
exactly. Exactly, sir. That is come in the design stage. So we are nullifying all this energy. Yes, in the design stage, sir.
Eye on the number
Yes.
of pumps and save on the motors, electric,
Exactly, sir. Ha, ha.
lighting, everything.
Exactly, sir.
When you reduce the number of pumps.
Number of pumps, sir.
Plus operation problem is there.
Yes, sir.
Right numbers means usually automatic circulation works for all the pumps.
Ha, ha, sir.
How they will be synchronized.
Exactly, sir.
So clearly means number of valves is there, more pumping valves is there.
Yes, sir.
So you look at the one is the TRB,
Eh, yes, sir.
pressure turbine, and there the boiler pit pumps.
Yes, sir. So in the PCB only just will exactly, sir. You will definitely take your point, sir.
Thank you,
Just
sir.
for the in the back pressure turbine installation, we are seeing if they in case of water, can we install the instead of PCB or back pressure turbine, sir? We will definitely work on it, sir. Okay, sir.
Okay.
Thank you, sir.
Thank you. Thank you. We terminate the session here. Now may I call upon the next speaker, who is going to talk about the optimization of energy consumption and implementing innovative energy conservation measures to reduce the specific energy consumption of a pipeline operation. Who is there? Mr. Dinesh or Hemant? Who is there?
MG Joy. Dinesh is not there.